This video is about polynomial regression. We're going to try to fit a curve to some data points. And in this case, the curve is going to be a polynomial. In number one, it's a simple parabola. I want to determine the best fit parabola that goes through the 3 points given. To draw a line, you need 2 points. To draw a parabola, you actually need 3. And so we can find a parabola that perfectly goes through these 3 points. What we'll do is we'll start with the general equation for the parabola, which is y equals ax squared plus bx plus c. Then what we want to do is we want to let x equals 0 and y equals 0 for one of the equations. Then we'll let x equals 1 and y equal 1 for the next equation. Finally, we'll use the third point, x equals 2, y equals 4. That would give us a system of equations with 3 unknowns and 3 equations that could be solved for the correct constants a, b, and c that would go through those 3 points. I'll try to simplify the equations. And now we'll try to solve the system by hand. We see that c is equal to 0. We want to now plug that into both of the equations to simplify them. Now I would solve both for a. I'll set the results equal. B must be 0. And now I could just plug that result in here to reveal that A is actually 1. So now that we know through algebra that A is 1, B is 0, and C is 0, we can now find the best fit parabola. It's y equals 1x squared plus 0x plus 0. Or in other words, y equals x squared. Luckily, with the use of technology, we don't have to do it by hand. I'm going to bring up the website desmos.com. And I'm going to put a table in of those points. So all right, there are the points. It looks like a parabola could fit this well. Now, let's plug in the formula that we had gotten. Y equals x squared. And look at that. It fits the 3 points perfectly. But let's say that we didn't know what the best fit parabola was. And we wanted to find it using regression. Type in y1 tilde ax1 squared plus bx1 plus c. Desmos will now tell you what the best fit A, B, and C are for that parabola. Let's use technology to do the next one. We'll have to change our points. We need 0, 2, 2, 6, and 4, 2. All right, let's use regression to get the best fit curve. Desmos tells us that A should be -1, B should be 4, and C is 2. Now all we have to do is put that into the formula. And that is our best fit parabola. Now when you have just 3 points and you're trying to find a parabola for them, it is always certain that you're going to be able to find a parabola that those 3 points are all on. But if we have 4 or more data points, it is possible they won't all lie on the same parabola. So in that case, we want to use quadratic regression to find the best fit statistical parabola that is closest to all of them. Let's try it in the next example. There's the data. Now it's possible they all 4 might be on a parabola, or maybe they won't. Let's find out. Okay, looks like they are not all perfectly on the best fit parabola. And we can tell from the r squared value, it's not 1. If it had been 1, then all 4 of them would have been on the parabola. Here it's quite close to 1 though, 0.998. That's pretty good. It's a good fit. Anyway, our A is 0.88. Our B is -5.58. And our C is negative 3.02. So let's write those down. Our regression curve becomes y hat equals 0.88x squared minus 5.58x minus 3.02. Let's check out the next data set. Now we could type in 1950, 1960, and so on. All right, there's our data. So now let's scroll out to see it. We'd prefer to get our data closer to the origin, if possible here. So rather than use x values of calendar years, I'm going to change them to years after 1950. So let's just start it off with 0. Then we'll do 10, 20, 30, and so on. That allows us to shift our data back to the origin. It's a little nicer to look at. And we'll get better constants to deal with too. So what we do in this case is we just write in t values as years after 1950. When I go back to Desmos, I want to change my x column to a t column. Okay, parabola is not a bad fit. But what if we go to a cubic model? That would be with a t cubed term. And this cubic model seems like it's a little bit better fit. So let's copy down those constants. All right, we'll put them into the mathematical model now. There we go. Now we have a cubic model. And the last two are going to be similar. The data here suggests a cubic model could be good because it looks like there is a peak. It looks like the data is rising toward a peak, then it goes down to a valley, and then back up again. So it seems like a cubic model might be a good fit here. Yeah, that looks pretty good. And look at the r squared value is 0.9896, very close to perfect correlation. So let's copy those constants down. Okay. The last one is Quartic Regression. That's got an x to the 4th term as well. And it's actually the same data set, So we can see which one is actually a better fit by looking at that r squared value. The r squared for cubic regression was 0.9896. Now let's add that extra term. Okay, wow. So this time our data is fit very closely to the curve, and our r squared went up. It went up to 0.9967. So it turns out that the quartic regression is actually a little bit better fit than the cubic. So let's write that model down now. And that'll do it.